Hi everyone, my name is Mwiza Chirwa. This is also another video and which we are going to start another topic in chemistry in Form 2. The topic that we are going to start looking at is known as hydrocarbons. So let us look at the success criteria that we are supposed to achieve by the end of this lesson. The following success criteria that we are supposed to achieve as follows. By the end of this lesson, you should be able to classify organic compounds. So in classifying organic compounds is too broad. What are we looking at? We are supposed to look at some teaching and learning activity under this success criteria. We're supposed to discuss families of organic compounds, that is hydrocarbons as well as oxycarbons, discussing the homologous series of alkanes. So under classifying of organic compounds, these are the teaching and learning activity that we are going to dwell much on it. So let us start. First of all, we're going to start looking at the definition of organic compounds. So what are organic compounds? Organic compounds fall under a branch of chemistry known as organic chemistry. Remember, in Form 1, we were introduced about the branches of chemistry. So when we'll be looking at organic compounds, it's coming from a branch of chemistry known as organic chemistry. So the definition of organic compounds, these are compounds that contains elements carbon in their molecule except carbon dioxide, cyanide, and carbonates. We're saying organic compounds are compounds that contains element carbon in their molecule except carbon dioxide, cyanide, and carbonates. Why carbonates, cyanide, and carbon dioxide are not organic compounds? Because they do not form a bond of carbon to carbon as well as carbon to hydrogen. So because they do not form carbon to carbon and carbon to hydrogen bonds, that's why they are not known as organic compounds. So carbon dioxide, cyanide, as well as carbonates, despite that they have the element carbon in their molecule, but they do not belong to organic compounds. The reason why they do not belong to organic compounds is because they don't form covalent bonds between carbon to carbon as well as carbon to hydrogen. So organic compounds are classified or grouped into two. We have this includes the following. We have hydrocarbons as well as oxycarbons. So we have two groups of organic compounds. We have hydrocarbons as well as oxycarbons. So we will look into details about these ones specifically. We are going to focus on hydrocarbons because that is based on our objective. For oxycarbons, we will just introduce the classes of oxycarbons, but later on in Form 3 is when you are going to learn about all those oxycarbons, members of oxycarbons. So let us start with hydrocarbons. So what are hydrocarbons? These are organic compounds that are made up of element carbon and hydrogen atoms only. They are organic compounds that are made up of elements carbon and hydrogen only. So it means in hydrocarbons, we are only going to find two types of elements, that is carbon and hydrogen only. So members or classes of hydrocarbons simply means hydrocarbons can be further classified into two. We have alkanes and alkenes. So these are the only members of hydrocarbons. So when we're talking about hydrocarbons, we'll only be focusing on alkanes and alkenes. Oxycarbons, that is also another group of organic compounds. It's known as oxycarbons. So what are oxycarbons? These are organic compounds that are made up of three different atoms or elements. What are these elements that are used to make oxycarbons? We have hydrogen, oxygen, and carbon. These oxycarbons are further classified as follows. We have alkanols, which are also known as alcohols. We have alkanoic acids, which are also known as carboxylic acids. We have alkanone, which are also known as ketone. We have alkanal, which are also known as aldehydes. Then we have alkanoate, which are also known as esters. So these are the members of oxycarbons. Remember, on hydrocarbons, we only have two classes. We have alkanes and alkenes. On oxycarbons, we have at least 5 classes. We have alkanols, alkanoic acid, alkanone, alkanal, as well as alkanoate. So these ones will all be covered later on in Form 3. But for us, based on our objective, we only focus on hydrocarbons, which are alkanes and alkenes. So before we go into details, we need to look into important definition of terms that we're going to be using in this lesson. We have homologous series. Homologous series. So what is a homologous series? Homologous series is a family of organic compounds. Family of organic compounds with the same general formula and functional group. With the same general formula and functional group. This means that all members possess the same general formula and functional group. What about a functional group? A functional group is a simple atom, can be a simple atom or group of atoms or a bond which join together that decide physical and chemical properties of all members. What about general formula? This is a mathematical expression that is used to show relationship between variables. So you have an expression that is used, for example, to find a molecular formula of an organic compound. That one is known as a general formula. So all members of the same family have the same functional group and general formula. The general formula, I've said that it is a mathematical expression that shows the relationship between two variables or between variables. So that expression in organic compound can be used to come up with a molecular formula of a certain organic compound. So saturated and unsaturated hydrocarbons. So hydrocarbons are either saturated and unsaturated. So alkanes are saturated hydrocarbons. What do we mean when we're saying that alkanes are saturated hydrocarbons? In their molecule, they only have a single covalent bond between carbon to carbon and so as carbon to hydrogen atoms. So in saturated hydrocarbons, you will not find double bond. There are always single bond between carbon to carbon and carbon to hydrogen. Remember, we said hydrocarbons are organic compounds which are made up of only two types of elements, that is carbon and hydrogen. These ones are covalently joined together. So they are known as saturated because they are always having a single bond throughout their molecule. So for example, if we may have a structure of methane, methane is a member of an alkane which has 4 hydrogen atoms bonded to a single carbon atom. So these are the hydrogen atoms which are bonded to this carbon. So since it is single bonded, it means this one is saturated. Alkane do not have a functional group. Does not have a group of atoms which can be used to define it, or does not have a double bond, but they use carbon to carbon and carbon to hydrogen single bond as their functional group. What does this statement mean? It means that in all alkane members of alkanes, you find that there will be a single bond between carbon to carbon and carbon to hydrogen. Their general formula, we said a general formula is an mathematical expression that is used to show the relationship between variables. So this is a general formula of alkane. We have Cn, H2n, and plus 2. What does the N stand for? Where N represents number of carbon atoms. So this expression, mathematical expression, is referred to as a general formula. So we can use this general formula to find the molecular formula as well as to find the alkane used and to name it, provided we are told the number of carbons. Alkenes are unsaturated. Now the difference between alkenes and alkenes is that alkenes are unsaturated hydrocarbons. What do we mean when saying unsaturated? They have at least a single bond, a single double bond, or triple bond in their molecule. When something is saturated, it means it has either a single or triple bond in their molecule. And this single or double bond, they can be many or it can be one, provided there is presence of a single or presence of a double bond or triple bond, that organic compound becomes unsaturated. So for example, we're going to look at the structure of ethene. Ethene has two carbon and 4 hydrogen, so it has a double bond here. Remember, it's carbon. Carbon is coming from group number 4. Its valence electron is 4. For it to be stable, it's supposed to gain 4 electrons, and in this case, since they are all nonmetals, it is sharing with other elements the 4 electrons to make it 8 here. So it has a double bond. That's why it is known as unsaturated. Alkenes have a functional group. Unlike alkenes, the functional group is carbon to carbon double bond, which is illustrated in the bracket here. It means at some portion we still have a double bond between carbon to carbon. The general formula of alkene, we have defined a general formula as a mathematical expression showing the relationship between variables is CnH2n. There is no plus 2 here because in an alkene you always have a double bond somewhere else, where n represents number of carbon atoms. Homologous of alkenes. So we said homologous, we are looking at family members of alkenes which have the same which have the same general formula and functional group. So what do we expect to all members of alkenes? First of all members have the same general molecular formula. Each member differ from the next in molecular formula by CH2. It means as we are going down, the members will differ by this CH2. The physical properties of members change gradually in the same direction along the series. Simply means as we are going down the homologous series, the physical property changes. For example, in terms of melting point as well as boiling point changes as we are moving from moving across the homologous series. All members show similar chemical reactions. It means they maintain to have the same chemical properties. They may all have the same general method of preparation. That is all about the members found in the homologous series of alkenes. Naming of alkenes is also known as common nomenclature of alkenes. So sometimes others may use common nomenclature, which simply means naming of alkenes. When we are naming alkenes, we use a suffix ane to a prefix. We are going to add this one to a prefix. We need to understand these terms properly, suffix and prefix, which comes first. So as we are going through, we'll be able to see which one comes first. So not all members of alkenes have the same suffix, but different prefix. So all members will have ane at the end, but will have a different preamble or the different prefix depending on the number of carbons. So the prefix changes because of the number of carbons. When coming up with prefix, we consider number of carbon atoms in the molecule related to a Greek prefix of naming, except the first two members of homologous series which they use met, which means 1, and eth, which means 2. So we have number of carbons here, a table showing that common prefix and common suffix, then the name of an alkane. So prefix comes first and suffix will be the last one. When we combine them, we're going to come up with a name. So for example, here we have 1, which is a prefix will be meth. We'll add N-A-N-E, it's methane. So we are going to add these ones to this one. So this one and this one, we don't use Greek prefix, but Greek prefix we start using from the alkane with the 3 carbons up to 10. So we have prop, we have but, we have pent, we have hex, we have hept. When we add Ne, we add Ane, we have propane, butane, pentane, hexane, and heptane. We can continue up to 10. We have octane, nonane, and decane. So, formula of alkanes. So we have structure formula. What is a structure formula? Because it's an organic compound, we need to know its structure. So it is a formula that shows the arrangement of carbon to carbon with attached hydrogens. We have it is a formula that shows the arrangement of carbon to carbon with attached hydrogens. Later on we're going to see how a structure formula look like. The second one is skeletal formula. What is a skeletal formula? A skeletal formula, it is a formula that shows the arrangement of carbon to carbon only. Remember, when structure formula was said, it shows the arrangement of carbon to carbon and carbon to hydrogen with attached hydrogens. But in a skeletal formula, we only find the arrangement of carbon to carbon only. So, example, we can have this one. This is an example of skeletal where hydrogens are eliminated. We can also represent using bonding lines like this one, where here we can have a carbon, carbon, carbon here, carbon there, and carbon there. Remember here there are 5, 1, 2, 3, 4, 5. Here we also have 1, 2, 3, 4, 5 carbons. So it's a pentane. So a structure, the skeletal formula can be written like this one or this one, depending on your preference. The third one is molecular formula. It's a formula that shows the actual number of atoms of each element in that particular molecule. For example, if you have C2H6, it means it shows actual number of carbons as well as hydrogen. This one is known as molecular formula. Then we have condensed formula. It is a formula that shows arrangement of atoms at each carbon atom present in a molecule. So it tells the arrangement of atoms at each carbon. For example, at the first carbon here, we have 3 hydrogen. The second carbon, we have 2 hydrogen. The third carbon, we have 2 hydrogen. The fourth one, we have 3 hydrogen here, and can be simplified in this way. Since we have these 2 CO2, we can put it in bracket and put 2 here. So this is a condensed formula, which shows the arrangement of atoms at each carbon present in the molecule. Okay, so we can use the general formula to identify the alkane as well as to come up with the different formulas that we have discussed so far. So, for example, we have an alkane which has 5 carbons. Determine the molecular condensed skeletal formulas and name the alkane. So this question can be answered properly if we use the general formula. We said a general formula is an arithmetic expression which shows the relationship between variables. So, for example, here it shows the relationship between carbon and hydrogen. So the general formula of an alkane is CnH2n plus 2, where n represents number of carbon. So in our questions, we have been given the number of carbon. So we are going to substitute the number of carbon in our general formula where there is n. So we will put 5 where there is n, and here if we multiply 2 times 5, we're going to get 10, and 10 plus 2 is going to be 12. So this, what we have come up with here, is known as a molecular formula. So an alkane with 5 carbons is known as pentane. So the name of this alkane is pentane. And the skeletal formula, we can use either the carbon chain without hydrogens or bonding lines. So since it has 5, it means we have 1, 2, 3, 4, 5, or this one. The condensed formula, this is the condensed formula of pentane. So in general, we can come up with all those using a table and looking at the name. So this is a table which simplifies everything. Methane, the structure formula looks like this one. Then a structure formula, we said, attach is a type of formula that involves the attachment of carbons with the hydrogen attached as well. So you can see here we also have hydrogens. They are attached. This is the structure formula. How do we of all members of alkanes in a table? So if you can check, this is methane, this is ethane, this is propane, this is butane, and this is pentane. The condensed formula. Now we need to be very careful when coming up with the condensed formula. So in condensed formula, we said we arrange atoms at each carbon. So for example, here we have one carbon. On one carbon, how many atoms are there? We have 4 hydrogen atoms. For here is a ethane. It has 2 carbons. At each carbon, we concentrate on each carbon. So first carbon, there are 3 hydrogens, and the last one, there are 3 hydrogens. If you go to the third one, that is propane. The first carbon has 3, the second one has 2, and the last one has 3. So this is how we come up with the condensed formula. The skeletal formula can be written using bonding lines like this. So here we have hexane, and here we have heptane, we have nonane up to decane. Now that marks the end of our presentation, but before we go, we need to go through our buzz session. In our buzz session, we always check our understanding based on what we have covered. So based on what we have covered, let us check if we can answer the following question. The first one, define the following terms: hydrocarbons as well as oxycarbons. Explain why alkanes are saturated while alkenes are unsaturated hydrocarbons. Explain the difference between molecular as well as structural formulae. Write the molecular formula of the following alkanes: decane, butane, and methane. So question number 5, we have to write the condensed formula of the following. We have hexane, propane. We should draw the structure of the following alkanes. We have ethane as well as we have this alkane with the condensed formula here. And the last question on the past session that we need to attempt is that an alkane has 12 hydrogen atoms. Work out the molecular formula of this alkane. So this marks the end of our presentation. If there are more questions, we can visit us through the WhatsApp number here, check on us, then you can check more on Xulendo.org for the materials that helps us to prepare the presentation. We have Excel and Succeed, Chemistry Book 2, Achievers Chemistry Book 2, as well as Target Chemistry Book 2. So for the photos that we have used, the following is a link that you can click to find and check for more photos. This marks the end of our presentation as well as lesson.